Yes, guys, so here we were supposed to draw the graphs of y is equal to a sine theta kappa a cos theta to see how a affects the original graph of y is equal to 2 sine theta. So we are able to see in class that a here, when a how ele positive and greater than 1, eba enlargement. So instead of your amplitude being 1, your amplitude is now 2 because mona re na le a2 ile a. And you were supposed to draw a graph of y is equal to 2 cos theta to also see hore now ha e sa tla qala mona e se tlo qala mona. And then this is how a affects the graph of either sine theta kappa cos theta. It affects the amplitude. We said that it affects the amplitude. Right. Yaba retla ho b. Ha retla ho b, we have y is equal to cos b theta, or we could even draw sine b theta. For one period. Re hopole re itse period ke wavelength. And normally, period ya rona ha re na le original sine kapo cosine curve, re itse original ya rona ke 2 pi, meaning original period ya rona ke 2 pi. Right? Yes. So, mona, we want to see how b affects our period, our normal period, which is 2 pi. Now, when drawing this, we realize hore, in class we did realize hore, we shall have a segment of the radians tsa rona ho tloha ho 0 ho fihlela ho 2 pi. It completes a full wave. Remember, this is a cosine, so it's a full wave ya teng ka re skotlolonyana. So instead of our period being 2 pi, our complete wave length is now 2 pi over 3. And so what we were supposed to learn in class is that now you can calculate a new period by having your original period 2 pi divided by whatever value of b you have. And in this case, because our b is equal to 3, our new period is 2 pi over 3. So, how so about our new period? This says to you that from 0 to 2 pi over 3, you have to have a full cosine wave. Right? Like we do here, the green graph. Jwale o tlo tseba jwang hore na e kata ho 0 kae? When does it become -1 and when does it become 1? That's very easy. The trick that I use is I know originally the graph of the sine or cosine in a little segment is a 4 for one period. Ailing from 0 to pi, I try to highlight with a green marker. Here from pi over 2 to pi is an orange marker. From here to here is a lime one and a pink one here. The idea is for you guys to see that you have 1, 2, 3, 4 segments. If you have these 4 segments, it will be easier for you to draw the graph. Also, it will, for the sine will go from 0 and increase and decrease and cut the x-axis and get to the minimum and then go back to the x-axis. So what happens with the cosine? Let's see what I did here. So we remember our new period will be 2 pi over b, and our b is 3, therefore we have 2 pi over 3. And we said that 2 pi over 3 is now a new wavelength. From 0 to 2 pi over 3. And I also know that you have to have 4 segments. So I'm going to divide this whole wavelength by 4 segments that we just saw earlier in the graph above. 2 pi over 3 divided by 4 is equivalent to 2 pi over 3 times 1 over 4, and this is 2 pi over 12 simplifies to pi over 6. What does this mean? It means that from 0 to pi over 6, it's the first segment. Segment it's now from 0 to pi over 6, not pi over 2. What must happen there for a cosine? For a cosine, in the first segment, from 0 to pi over 2, re tloa ho 1 re ya go kata x-axis. Now, ha re sa lo e kata mane on the original curve, our first segment now cuts here at pi over 6. Okay, so I would say let us name pi over 6 an increment. How we are going to go from 0 and with an increment of pi over 6, and then add pi over 6 because this is the length of each segment here. Right, so our first coordinate on the x-axis, re tlo tloa ho 0 akere, ebe re kopanya pi over 6, and then we get pi over 6. And pi over 6 plus pi over 6 is pi over 3. And pi over 3 plus pi over 6 is pi over 2. And then we end up with 2 pi over 3. For these coordinates, we are going to have a full wavelength. So, mona he ke mo ntse ke kopanya fela. I know I taught you how to add this and you already know how to do it. So, our first coordinate is 0. Our first coordinate is 0. Kiena elatelwa ke pi over 6. Kiena pi over 6. Elatelwa ke pi over 3. Kiena pi over 3. Elatelwa ke pi over 2. Here's our pi over 2. And then the last one is 2 pi over 3 again. So how do you use these coordinates now that we have marked on the x-axis? For a cosine, cut your x-axis, get to the minimum, to the x-axis, and then end here. And I'm going to try and draw the graph of sine b theta now without the original curve. Mona ene le go fela le bone hore period ya gona ya chincha. Length ya gona ha e sa le telele se ba khutshwane. And let us draw a graph of y is equal to sine maybe 2 theta and see how it's affected. Alright, so we have our equation y is equal to sine 2 theta. The first thing that we must find is what is the period. We know the amplitude ke 1 already. Focus on b for now. So our new period would be 2 pi over b, which is 2 pi over 2, which is pi. Yes, you're always going to divide 2 pi by b. You're going to start here for each function that you are given. Right. So this says to us that our new wavelength is pi. Now, we should have a complete sine wave. 4 segments. Remember the segments that we saw earlier. So our segment kappa increment, it's for me, or increment this new period, which is pi divided by 4. So let me write it down so you won't forget. It's our new period divided by 4. So keep period in pi divided by 4. Right. Surely, what does this tell us? The coordinates it's on the x-axis. Coordinates on the x-axis, we are going to start from 0. Pi. 0 plus pi give pi. Pi plus pi. Sorry. Re kopanya 0 le increment. Pi over 4. Right? And then pi over 4 plus pi over 4 ebang pi over 2. And then pi over 2 plus pi over 4. Let's see what it gives us. Pi over 4. Pi over 2 plus pi over 4. Common denominator here. Then we have 2 pi plus pi, which is 3 pi over 4. So this is our fourth coordinate. 3 pi over 4. And lastly, 3 pi over 4 plus pi over 4 should give you 4 pi over 4, which is pi. So we have a complete wave from 0 to pi. Remember that this is our new period. Usually here we're going to use this coordinates to draw our sine 2 theta, right? Usually Mona would be as 0, and then our pi over 4, and then pi over 2, and 3 pi over 4, and lastly at pi we should have a complete wave. And how are you going to draw this curve? You know, from sine, you start from here, you get a peak there, you cut the x-axis right there, you go to -1, and you end here. It's as easy as it can be. And now I would want to challenge you on your own. Draw the graph of y is equal to cos say 4 theta for 1 period. We can't do a lot of periods because we are working against time. So for 1 period, meaning for 1 wavelength, like we did here. So challenge yourself to get this one right.